Nice.
Let's solve this trig equation. Notice it's a quadrat. There's a square in it. Whenever you see a square in it, and whenever you see it not in terms of sine and cosine, you should probably think, I'd like to get this in terms of sine and cosine, so let's do that. Let's make this 1 over sine squared of x, and cotangent is cosine over sine.
Oh. Is the number always going to be on top then?
Yeah, the
Okay.
number, because that's 4 over 1, right? So now I'm going to multiply everything by sine squared. There's other ways to do this problem, but I would prefer to do it this way. So when I multiply everything by sine squared, because it's called clearing the fraction, sine squared is the least common denominator, I get 1 minus 4 sine x cosine x equals negative 2 sine squared x. And as I do that, I recognize, you know what, I don't really want to do it that way, because that's going to involve some stuff that you haven't learned yet. So let's change this. Sometimes you do this when you're solving math problems. You start in one direction and you realize, you know, that's not really what I want to do. It's not giving me what I need. So instead, I'm going to take a little bit of a different path. I'm going to convert this one. Remember that I have sine squared plus cosine squared equals 1. If I divide all of that by sine squared, I'm going to get 1. So I'm simplifying this. 1 plus cotangent squared x equals cosecant squared x. You see that? Which means that right there, I could replace with that. If you had your trig identity sheet, you could have found that way too, but I don't memorize those. I just create them when I need them. So you remember your basic sine squared plus cosine squared equals 1. If you divide all those by sine squared, you're going to come up with another property, identity, that you can use, because you'll notice that the cosecant and the cotangent both have a denominator of a sine. So when I do that, I can rewrite 1 over cosecant squared, I can rewrite as 1 plus cotangent squared of x minus 4 cotangent x equals negative 2, and now I have an equation in terms of cotangent squared, or cotangent x. So I'm going to move everything over. It's just a quadratic equation. I'm going to set it all equal to 0. Cotangent squared x minus 4 cotangent x plus 3 equals 0. Now I can factor that into cotangent x, negative 3, negative 1. That's how that factors. If you don't remember how to factor, you can go back and review that. I'm not going to spend the time to re-explain that. Hopefully that makes sense. And so now that I've got that, I can set each one equal to 0, which means cotangent x minus 3 equals 0, and cotangent x minus 1 equals 0, which means the cotangent of x equals 3, or the cotangent of x equals 1, which means the sine, I'm sorry, not the sine, that's cotangent. The tangent of x equals 1/3, because it's the reciprocal, and the tangent of x equals 1. So I'm going to solve each one of these equations for x now. So this one right here, I'm going to change colors. This right here can't be solved with a unit circle, because on your unit circle you never have a tangent of x. Tangent of something in unit circle does not equal 1/3. It equals 1 over root 3, but that's different than 1/3. So to solve this one, you need to actually just punch it into your calculator, do the tangent inverse of 1/3, punch that into your calculator, and this is kind of tricky. You're going to get 0.322, but remember that's just one of your answers, because you also, think about your unit circle, where else does the tangent inverse, when you punch your tangent inverse in your calculator, again you might have to go back and review this, you're going to get an answer between negative pi over 2 and positive pi over 2, because that's the range of that function. So I'm going to get one, obviously the tangent being 1/3 would be in this quadrant right here somewhere, so that right there is my angle 0.322, but I also would have that same angle over here, pi away from it, right here, because in the first and second quadrant, I'm sorry, not there, pi away is all the way over here. That's where the other one's going to be. Because where else is the tangent positive? First quadrant and third quadrant. Remember, they wanted answers between 0 and 2 pi, so I'll get 0.322 and 0.322 plus pi. You can just write it like that. So those are the two answers that come from this particular one, 0.322 and 0.322 plus pi. I'm kind of running out of space over here, so I'll write it over here, 0.322, 0.322 plus pi. So there's two answers, x equals that, and now I've got to find the two answers that come from this. When does the tangent of x equal 1? Well, that is on my unit circle, so I don't need my calculator for that. So if you look at your unit circle, where does the tangent equal positive 1? And you'll see that tangent's in green here. The tangent equals positive 1 at pi over 4 and 5 pi over 4. Those are the two places that the tangent equals 1. So x equals pi over 4 and x equals 5 pi over 4. So there are 4 solutions for this equation up here. 4 solutions are, I'll write it up here, 0.322 roughly, 0.322 plus pi, whoops, plus pi. Oh my goodness, I keep touching the button. Alright, you know what I'm saying, that's pi. Pi over 4 and 5 pi over 4. Those are the 4 solutions. Right there. X equals those 4 things.